We're going to look now at stretches that can be horizontal and vertical. So this is the second part of the movie. We started last time with translations. So let's look what a stretch means, a horizontal stretch. So the green function is stretched horizontally. And see, it can mean a dilate or a compression, a stretch. That's a dilation. And soon we are going to see a compression. Both of them are called stretches. We don't really use in math dilation and compression. So I'm going to stop the movie at a stretch by a factor half. So this is defined as a stretch, what you see, by a factor of 1/2. Factor of 1/2 actually tells you that it's a compression. Let's see how the red graph is obtained from the green graph. So the equation of the green graph is f of x equals x squared minus 2x. I started with the same. The coordinates of the point on the green graph are x old, y old. Let's see what happens with the compression. So if we look at this point here, which has the coordinates a of coordinate 1, -1, it is compressed into the point here, which has a coordinates b of coordinates 1/2, -1. So as you can see, x new is 1/2 times x old, but y new stays the same as y old. Therefore, same as before, I will need to get the equation into the in terms of the new coordinates. So my old equation was y old equals x old squared minus 2 times x old. These were the points on the old equation. Now on the new equation, y new is the same as y old, so I can replace it here. But x old is 2 times x new. And the other x old is the same 2 times x new. So see how your new graph, let's call it g of x, which is y new, is actually f of 2x. Instead of x, we have 2x. So as a conclusion, you can try another graph. So stop the movie and try yourself a stretch, horizontal stretch, by a factor of 3. Think what happens with the point A by a factor of 3. It will move to this point here. Yeah, and see, stop the movie and think how we get the new equation. So your equation will be h of x will be f of 1/3x in your case. So I hope you all found this. Let's write a conclusion. So our conclusion is that f of ax represents a horizontal stretch by 1/a. So if a is bigger than 1, then it's a compression. If a is smaller than 1, then it's a dilation. This compression and dilation happened along the y-axis. So see how the point on the y-axis is fixed here, it stays as it is. Yeah, so it's like it's fixed on the y-axis and it dilates or compresses away or toward the y-axis. Let us now look at a vertical stretch. What does it mean? So I'm stretching the function vertically, and see, it's like it's fixed on the x-axis. Those points stay. So I stretch it vertically. Same vertical stretch. Yeah. I combine it with the reflection as well. I'm going to talk about the reflection later. So here I'm combining stretches with reflection. Now we have a stretch. So the movie stopped at a vertical stretch by a factor of 2. So it's stretched away from the x-axis. The point here, A, of coordinates 1, -1, becomes B of coordinates 1, -2. So my function was y old. Let me write it with green because it was green. Y old was x old squared minus 2x old. This was my function. Y equals x squared minus 2x. Now I see how x new is the same as y new. Sorry, x new same as x old, and y new is 2 times y old. Therefore, if I replace in the equation, so a f of x is a vertical stretch by a factor of a. If a is bigger than 1, it goes away from the x-axis, and if a is between 0 and 1, it goes towards the x-axis. So your function that was stretched by a factor of 1 over 3 will come something like this, right? That's what you got. You always can check it using GeoGebra. Now you are one step away from discovering reflections on the x-axis and y-axis. Let us look at the reflection on the x-axis. Imagine what this curve would be if you reflect it on the x-axis. And it will come like that, right? Something like this. So the point here will be reflected on the point somewhere here. So if we look at same approach as before, x new is going to be the same as x old, and y new is going to be minus y old. Therefore, if your green function is y old equals f of x old, whatever the function is, your new function will be minus y new equals f of, and x old is the same as x new. So your function will be y equals minus f of x. And this represents a reflection on the x-axis. What a reflection on the y-axis will look like? Well, maybe that's not the best function to reflect, because when you reflect it, this point will come here and this point will come there. So the shape will stay into itself. But we can imagine, right? Think of this point here, let's call it P, which is reflected into the point Q. So your x new for point P is going to, for point Q is going to be the minus x old. And your y new is going to be the same as y old. So from your green equation here, if we write the new equation, we have y old is the same as y new equals f of, and x old is minus x new. So your new equation reflected will be y equals f of minus x. And this is a reflection on the y-axis. On this page, you have a summary of all transformations of functions that we studied.